Hello guys, I am Gaurav Sarayavala, UG student, CSC branch, and today I am going to explain you about what are asynchronous counters. But before that, you should know what is a counter. A counter is a device which stores and sometimes displays the number of times a particular event or process has occurred. Often in relationship to a clock signal, counters are used in digital electronics for counting purposes. They can count specific event happening in a circuit. Counters are of two types: asynchronous or ripple counters and the synchronous counters. What is a synchronous counter? In a synchronous counter, the clock inputs of the flip-flops are connected together and all flip-flops are simultaneously triggered by the common clock. Consequently, all of the flip-flops change state at the same time in parallel. Like you can see, all the clocks are simultaneously connected in all the four flip-flops, and QA, QB, QC, and QD are the four outputs given. It is the circuit of the synchronous counter using four flip-flops. What is a asynchronous counter? Asynchronous counters are those whose output is free from the clock signal because the flip-flops in asynchronous counter are supplied with different clock signals. There may be delay in producing output. The required number of logic gates to design asynchronous counter is very less, so they are simple in design and it is the advantage over the synchronous counter. Another name for asynchronous counter is ripple counters. The number of flip-flops used in a ripple counter is depends upon the number of states of the counter. Example mod 4, mod 2, etc. The number of output states of a counter is called the modulus or mod of the counter. The maximum number of states that a counter can have is 2 into n, where n represents the number of flip-flops used in the counter. Now the circuit of the asynchronous counter, like you can see that the all clocks are not simultaneously connected. The previous output is connected to the clock of the next flip-flop. And in this also Q0, Q1, Q2, Q3 are the four outputs. And they have used the four flip-flops. Now, different types of asynchronous counters. There are many types of asynchronous counters available in digital electronics. They are 4-bit asynchronous up counter, 4-bit asynchronous down counter, and 3-bit asynchronous up and down counter. 4-bit asynchronous up counter. A 4-bit asynchronous up counter with a D flip-flop. It is capable of counting numbers from 0 to 15. The clock inputs of all flip-flops are cascaded and the D input, data input of the each flip-flop is connected to a state output of the flip-flop. Like you can see, the data input is connected to the state output of each flip-flop. Asynchronous 4-bit down counter. A 4-bit asynchronous down counter, it is a simple modification of the up counter. A 4-bit down counter will count numbers from 15 to 0 downwards. The clock inputs of all flip-flops are cascaded and the D input, data input of each flip-flop is connected to logic 1. The 4-bit asynchronous down counter. Here we have used the D flip-flop. Q0, Q1, Q2 and Q3 are the four outputs and the data input is shown to the previous state output. It's connected to the previous state output. And the present output is connected to the clock of the next flip-flop. Asynchronous 3-bit up and down counter. Up counting. If the up input and down inputs are 1 and 0 respectively, then the NAND gates between the first flip-flop to third flip-flop will pass the non-inverted output of flip-flop 0 to the clock input of flip-flop 1. Similarly, the output of flip-flop 1 will pass to the clock input of flip-flop 2. Thus, the up and down counters performs up counting. Like you can see in the up counter, disconnected like this. 3 flip-flops are used. We have used the GK flip-flop. Now for the down counting, if the down input and the up inputs are 1 and 0 respectively, then the NAND gates between the first flip-flop to third flip-flop will pass the inverted output of flip-flop 0 to the clock input of flip-flop 1. Similarly, the Q output of flip-flop 1 will pass to the clock input of flip-flop 2. Thus, the up and down counter performs the down counting. Like you can see, the previous state is connected and it is given to the clock using the NAND gates. We have used the 6 NAND gates and it is a JK flip-flop. In Q0, Q1, Q2 are the three outputs for both up and down counting. Now, some of the advantages of the asynchronous counters. Asynchronous counters can be easily designed by T flip-flop or D flip-flop. These are also called as ripple counters and are used in low-speed circuits. They are used as divide by n counters, which divide the input by n, where n is an integer. Asynchronous counters are also used as truncated counters. These can be used to design any mod number counter, example even mod 4 or odd mod, example mod 3. Now some of the disadvantages. Sometimes extra flip-flop may be required for resynchronization. To count the sequence of truncated counters, mod is not equal to 2n. We need additional feedback logic. While counting large number of bits, the propagation delay of asynchronous counter is very large. For high clock frequencies, counting errors may occur due to propagation delay. Now, it's time for some of the applications of asynchronous counters. Asynchronous counters are used as frequency dividers as divide by n counters. These are used for low power applications and low noise emission. They are used in designing asynchronous decade counter, also used in frame counter and Johnson counter. Asynchronous counters are used in mod and ripple counter, example mod 3, mod 4, mod 8, mod 14, mod 10, etc. What is a decade counter? BCD or a decade counter circuit. A binary coded decimal is a serial digital counter that counts 10 digits and it resets for every new clock input, as it can go through 10 unique combinations of output. It is also called as a decade counter. It counts from 0 and ends at 10 and again at 10 a new cycle starts. We use the 7490 BCD counter. The 7490 integrated circuit is basically a mod 10 decade counter that produces a BCD output code. The 7490 consists of 4 master slave JK flip-flops internally corrected to provide a mod 2 count to 2 counter and a mod 5 count to 5 counter. The 7490 has one independent toggle JK flip-flop driven by the clock A input and the 3 toggle JK flip-flops that form an asynchronous counter driven by the clock B input, as shown in the diagram. Like you can see the clock A, clock B. It is a 7490 IC in which QA, QB, QC, QD are the 4 flip-flops output. S1 and S2 are the set state and R1 and R2 are the reset state. It is connected to the 7447 IC, which is the 7-segment display, which is used to display the counting of the numbers. Like for 0, A, B, C, D, E and F will be high. For 1, B and C will only be high. And according to that, it shows from 0 to 9 and again at 10, it will again shows 0. Thank you guys for watching my video. Hope you like this video.